p.4b. All right, we're going to do more lines. We're going to do a lot of equations of lines. And we're going to do some application problems too. Some real-world problems. When are we ever going to use this? Today. All right, here we go. Letter A. Let's talk about two very important types of lines. We got parallel and perpendicular. Okay, and you know a couple of things about these about lines that are parallel and lines that are perpendicular. At least I hope so. First of all, what do we know about parallel lines? Parallel lines have the same, there's an S, slope. Yes, parallel lines have the same slope. Okay, they have to. They're not touching each other. They're rising and running the same amount as one another. They're called parallel. So we say that M1 is equal to M2. So if I have line 1, line 2, the slope of M1 and the slope M2 will be equal to each other. All right. The other thing is perpendicular lines. What do we know about perpendicular lines? Well, perpendicular lines have, yes, very good, opposite and reciprocal slopes. Okay, so perpendicular lines, I abbreviated perpendicular, I don't even know how to spell it. I don't know how to spell it. Perpendicular lines have opposite reciprocal slopes. So you could say that, you know, here's a line, and then there's another one. You can obviously see that if those are perpendicular, you can obviously see that one's positive and the other one's negative. Okay, so they have to be opposite. So we say that M1 is equal to negative 1 over M2. It's kind of a fancy way to write it. But you remember that? We learned that back in probably Algebra 1. Did a lot of it in Algebra 2. Okay, so now we're going to do 2 examples. We are going to need our calculators because we're going to graph a couple of these on our calculators. So let's go ahead and start number 1. You can get your calculator out. We don't need it for the first problem. We'll need it for the second problem. All right, we're going to find an equation. And with your test coming up in a couple weeks from now, or a week and a half, the first 4 problems on the test are find an equation of the line. And then you have to, you know, given some stuff, find the equations of lines. So be ready for that. So find an equation in slope-intercept form. I will always tell you which form I want it in. Find an equation in slope-intercept form that has point P at 1, negative 2 and is parallel. So find an equation in slope-intercept form that goes through, I didn't want to write all that stuff, but it goes through point 1, negative 2, and is parallel to this line right here. 3x minus 2y equals 1. All right, so this is enough information for us to find our equation for the specific line. We already have half of what we need. Normally you need a point and you need a slope, right? That's really all you need. So we have a point, so that's good. We have part of it. And now all we need is the slope. And, of course, they tell us that the lines are parallel. So if the lines are parallel, it's going to have the same slope as this line. So what is the slope of that line? Well, I can't see that yet. So what should we do?
Freshmen with last names D through I, please come to the attendance desk for pictures.
Okay, so you know what we should do. We should solve for y and find out what the slope is, right? So let's subtract 3x to the other side. And then we'll divide everybody through by negative 2. So I get 3/2 x minus 1/2. Okay, so we have everything we need. I'm going to have the same slope because they're parallel. And I have that point right there. So let's go ahead and put this into point slope form. Am I doing everything okay? Okay. Because sometimes you get quiet and I think I made a mistake. Because I make lots of mistakes. Let me know if I do. I don't want to get all the way down to the end of the problem and you're like, oh, by the way, it was negative. Okay. So we'll go y plus 2 equals 3/2 x minus 1. Do you like fractions? Yeah, you do. And then go ahead and distribute. So we'll go y plus 2 equals 3/2 x minus 3/2. Okay. And then we'll subtract 2 to the other side. And 2 is the same thing as 4/2, right? So we have 3/2 x minus, and we're going to subtract 2, which is 4/2, so that makes 7/2. Kind of ugly dealing with fractions. If you need to use your calculator, go ahead. Be slightly embarrassed, but go ahead. All right, any questions on that one? Pretty good? Yeah, these are basic. These are just like what you've done before in the past, nothing new. Okay, let's do number 2 now. So for this one, we have the same type of problem. We're going to find the equation of the line in slope-intercept form. Find the equation of the line in slope-intercept form. And we're going to be given kind of the same type of thing. The point is 2, -3. And this time, we're going to be perpendicular to 4x plus y equals 3. Find the equation of the line in slope-intercept form, goes through the point, 2, -3. This time we're perpendicular. Okay? Same idea, same type of problem. We have a point, which is great. We'll hang on to that. And now we need to figure out what the slope is of ours. So let's figure out what the slope is of this line right here. This one's a little easier. We'll just subtract 4x and we'll get it. 4x plus 3. Okay, so the slope of that line is -4. So then the slope that I'm going to need is going to be what? Perfect. Good. Good. Positive 1/4. So opposite reciprocal. All right. And then you know the drill. We're going to go with y plus 3 equals 1/4 x minus 2. And distribute. It would have been nice had I said just leave it in point slope form, but I didn't. 1/4 x. We're going to graph this one on our calculator. And then 1/4 times 2 is 1/2, -1/2. And then subtract 3 to the other side, and subtracting 3 is the same thing as 6/2. So y equals 1/4 x minus 7/2. And there's our equation. All right, so I want to show you on your calculator, we're going to graph 2 lines together. We're going to graph the one that we just found, and we're going to graph the one that they say that our line is perpendicular to. We're going to graph both of those in the same viewing window, and they're not going to look perpendicular. But then we're going to fix it, and I'll show you how they do look perpendicular. Okay, so go ahead and get your calculator out, and we'll go ahead and plot both of these. So -4x plus 3 and 1/4 x minus 7/2. Now, if I push zoom 6 and I graph these 2 lines, so here comes this one. This is the, and oh, they're graphing kind of at the same time. Those do not look perpendicular, do they? No. Now, I'll tell you why. Did we do it wrong? No. What's wrong is our window is a rectangle, and the window is -10 to 10, -10 to 10, so it's a little distorted. So if you want to, you can fix that into a non-distorted window. So you go to zoom, and you do zoom square, zoom 5. And so now this window, does that still look perpendicular? Does yours look perpendicular? It's better. Oh yeah. If you turn it sideways, that's totally perpendicular. You can see. But what they did was, and if you look at the window, it's really interesting. The x's are now -15 to 15 because it's a longer space, and everything's all like the same amount each way. Okay? So kind of interesting. You can check your answer if you want to. Take a look at that. All right, let's move on to part B. Part B. We're going to do some applications. I have 2 problems for you. and then you'll get a chance to work on your homework. Yay. All right, applications. Okay, so here we go. It says here that an apartment building was purchased for $50,000.
Freshman with last name J through M. J through M. Come to the attendance desk for pictures. Thank you.
You're welcome. All right, an apartment building was purchased for $50,000. I'm not sure where this apartment building is. It's not around here. Okay. Can't get anything for that. And for tax purposes, it says its value depreciates. Oh, this is not a good investment. So the value of this apartment building depreciates, which means it goes down. It says here, $2,000 per year. Ooh. Over a 50-year span. It's really sad. Okay, so we're going to write an equation. We're going to assume that this is a linear, these are all going to be linear problems here. So we're going to write an equation, because this could be, depreciation could have been exponential. Remember we did that? Exponential decay, like the value of something, it decays. Okay. But this is just 2,000 per year. It's not a percentage. We're going to write a linear equation giving the value y of the building in terms of the years x after purchase. Okay. So this one actually is pretty easy because you already have everything you need. The apartment building was bought at $50,000. That is your y-intercept. Your y-intercept is, see, whenever x is 0 for time, that was 50,000. That was exactly where it should be. So that's your y-intercept. And then 2,000 per year, that's your slope. That's the rate that it's changing, except for it should be what? Negative. Very good. So you already have everything you need, right? It's a pretty easy one. You've got the slope, you've got the y-intercept. Let's put it into slope-intercept form. So I've got y equals negative 2,000x plus 50,000. Okay, so first thing, just write an equation. And then the second part of this is going to ask you a question. And it'll be something like this. In how many years will the value of the building be 24,500? So they want to know in how many years is the value going to be 24,500. Okay. Now, it told us in the first part, it said y is the value and x were the years. Okay, so that's pretty important. So when I plug this in to my equation, because we're going to plug it in, do I plug it in for y or for x? For y, exactly. So we're going to take that, plug it in for y. Unfortunately, it's easier when you plug in for x, because now you actually have to solve this thing. But you guys are good at solving equations. Ew, that was gross. Plus 50,000. Okay, now you guys are at a point in your life where, you're pretty good at math by now, right? Yeah, some of you are like, yeah, I am. Do you think I'm going to ask that you show work on this? You don't have to. Okay, this is a two-step problem, two-step solving problem. You can do this on your calculator. You can do this in your head. Subtract 50,000, divide by negative 2,000. I'm not going to make you write all the steps out, okay? I make my Algebra 2 students do that for sure because, I'm not sure about them. Okay, here we go. 24,500. I'm going to subtract 50,000 from that. And then I'm going to divide by negative 2,000. There we go. All right, if it's a word problem, if the problem has words, your answer will have words. Okay? So 12.75 years. There you go. So $24,500 it's going to be worth in almost 13 years. Not a good investment at all. They should rethink that. Okay, one more. This is the hardest one, but it's not too bad. All right, number 4. Last one for today. This went by pretty quick, huh? Yeah. Okay, it says here that Americans' total personal income in trillions of dollars is given in figure p.4b. It's in your book. Okay. So letter A, we are going to write a linear equation for the Americans' income y. So income is going to be our y value. And years are going to be x. And we are told that in 2005, okay, the total income of America in trillions of dollars was 10.5 trillion. I was a small part of that in 2005, very small. Okay, and then it says in 2010, in trillions, you think it's going to be more or less? It's more. $12.4 trillion. I was a little bit more part of that one too. All right. So it says we're going to write a linear equation given those 2 points. So we're going to write a linear equation. And that was nice. They even gave it to you in point form. Sometimes they don't. Sometimes they'll say, you know, in 2005 it was 10.5, and you have to figure out where it goes in a point, x and y. But they'll tell you what x and y are too. All right, so what's our first step here? We have 2 points. We find the equation. We're going to find the slope. Yes. All right, so let's do it. We have 12.4 minus 10.5 over 2010 minus 2005, which is going to be 5. And so the slope ends up being, what is it, 0.38. 0.38. All right, so we're making more money. $0.38 per year. If you want to write that in, you can. Money per year, you don't have to. Slope is a rate, okay? It's like miles per hour, cookies per minute. Cookies per minute is my favorite rate. Like 40, like 3 cookies per minute, 40, I don't know. All right, okay. I'm moving you to the back because you don't laugh at any of my jokes. I'm over it. It's only like day 3. All right, here we go. Let's see. So I've got slope and I've got a point. Let's go ahead and put this into point slope. We've done this so much, huh? Are you getting sick of it? Don't say yes. All right, y minus 10.5 equals 0.38 x minus 2005. I just chose that point. I don't know. You don't have to. It's fine. Now, did they say which form they wanted in? No. You can leave it like that. They usually want it in point slope form. Okay, so let's do that. So we'll go y minus 10.5 equals, and we'll distribute. So we'll go 0.38 times 2005. Real life problems, they get a little ugly, don't they? That's okay. So that would be minus 761.9. And then we're going to add 10.5 to the other side. So you should get 0.38x minus 751.4. Okay, yeah? Ooh, good. I got some head shakes on that one. Good.
Freshmen with last names N through R, last names N through R, please come to the attendance desk to have your picture taken. Thank you.
Okay, nice. All right, so then finally, was that just A? Okay. B is now going to ask you something like, let's go ahead, if the model stays the same for a while, let's predict the income of all Americans in the year 2017. I wonder if we can look that up. Probably, right? There's probably some record of it somewhere. All right, so we're going to take 2017 and we're going to plug that in for X. So let's do it. We got 0.38 times 2017. I didn't do 2018 because it's not over yet. So I kind of want to look this up, see if it's right. The book actually does pretty good on, you know, its facts and stuff. It's not just making stuff up. So the answer would be 1506. Is that the correct answer? Did Americans make $15.06 in 2017? No. We need to write what? Trillion. Is it trillion or trillions? 15.06 trillion? Doesn't matter. It's pretty good. That's a lot, huh? Yep. Okay. That